And yeah, great talk, Sammy. Cannot stress enough what Sammy said about LaTeX it's the way forward. The learning curve might be a little bit steep or to start getting used to it, but once you start using it, you'll never ever look back. So cannot just reiterate that enough. But yeah, on to Git and GitHub. So there were a few prerequisites, I think, beforehand if you wanted to code along with me. So one of those is to make sure you've got a free GitHub account. You can just go onto Google GitHub, go on there, and you can make your account on the website there. And if you do want to code along, if you're on Windows, open up Git Bash like we did in the first Python session. Or if you're on a Mac, open up a terminal. And I will share my screen now. I think it's this one. Okay. Can everybody see my terminal? Yes, I've got a thumbs up from Nikki, so that is brilliant. And I will just try and get the questions up, or the chat up in front of me, sorry, just in case any questions come through. So yes, I'm going to talk to you about Git and touch very slightly on GitHub, but Sammy and I will do a live demonstration of how to use GitHub collaboratively in the next session. But more explicitly, I suppose I'm going to cover everything from an explanation of what version control is to creating and adding files to things called repositories and using branches, and then finish off with how do we tie everything together and make this into a useful tool. And I probably said quite a lot of alien words there, but as we go through this tutorial, hopefully a lot of those words, if they don't mean anything to you now, you'll understand a bit better later. So the first thing I think, if you're coding along with me, that we need to do, and if you were here in Python 1, is we need to make a new environment, virtual environment. So here we have, oh, I've got someone to admit here. We use the command conda create /name, and I'm going to call this S4S Git demo environment. And we always have to, even though we're not going to be using Python today, we have to specify which version of Python we would like to use. And this should create my new environment, and you can call your environment anything that you like. I would suggest you call it something descriptive that you're going to understand when you come back to look at it in next week, 6 months' time, whenever that might be. If you were here in the Python course a couple of weeks ago, you would have seen that most of my environments do not have descriptive names, and that is a very bad way of doing things. Bash conda command not found. So that will mean that some people weren't here in the Python tutorial. And if that is what's happening, you will need to have downloaded Anaconda before you can create an environment. Now, that's not to worry. You can do this in your base environment. But you will have to just be a little bit wary that you'll be putting some files and folders into the base environment. So I'm going to activate my new environment, which we called something up here. There we go. Right, so now we've got our environment done, we can start doing Git and version control things. But first of all, what is version control? Well, if you're carrying out a project that involves coding or programming, you're probably going to have quite a big code base build up as you go through. And there's probably going to be lots of times where you are doing trial and error. Some things are going to work, some things aren't going to work. And with that, there'll be many revisions to the programs that you're writing. And this is where version control will help you, because it can really be thought as a saving, I suppose, as a way of saving your programs for your project. And By doing this, you can track and log any changes that are made to your files. So this is version control. You are tracking and logging which version of the work you are currently working on. And you can also go back and restore earlier iterations. So if you break everything, then it's fine. You can go back to an earlier version that worked and rebuild from there.
Sorry, Sam, is there any chance you can zoom in your terminal screen a little bit? It's a bit hard on some of the smaller screens, I think.
Let me see if I can get my top up here. There we go. View. We go.
Oh, that's much better. Thank you very much. Yeah, that's much better. Yeah.
Fantastic. So yeah, that's version control. It's a way of restoring or saving what you're doing with your program as you're writing it. So how does this link into sort of Git and GitHub? Well, as I said, we'll talk about GitHub later on, and Sammy and I will give a demonstration. But Git is a version control system that allows you to manage and keep track of your the history of the project locally on your machine, whereas GitHub allows you to manage your Git repositories on a cloud-based service. And so GitHub is an online store, whereas Git, which I'll be showing you to begin with today, is local to your own machine. Don't worry that they're two different things, because they work hand in hand, and all of the commands are exactly the same, whether you're working locally or on the cloud. So any new project will start with creating what's called a new repository, or a repo is what a lot of people call it. And if you're looking at these things online, as all of us do, and you're looking for answers on things like Stack Overflow, people will refer to a repository as a repo. And we can create our new repository, which is where we are saying this is where our code's going to go, very, very simply. And the first thing that you might have seen that I've already done is I've created this S4S Git demo folder on my desktop. And so my repository is going to be in this folder, but you can put it wherever. There's nothing stopping you putting it on your desktop, in a different folder. It really doesn't matter. So to initialize a repository, we simply type git init. And we will see that what comes up is it says initialized empty Git repository in my new folder. And as you see, as I said before, I've just made a folder called S4S Git demo on the desktop. And this is now initialized an empty repository. And you know it's empty because it says, it comes up in the text here, initialized an empty Git repository. So everything is really quite explicit, and it comes up on screen, which is a fantastic feature of this, because you know exactly where you are and you know exactly what's going on. Now I want to create a demo file to put into this repository, because in real life, you will be having your code files or your text files that describe what you're doing. You're going to want them to go into this repository. So just to very quickly make one, I'm going to make a new file called test new file.txt. And this is simply, the touch command is simply a bash command to say, I want to put something in here. And I've just named it here, test new file.txt. And you'll see that I put underscores between each of the words. And I suggest you do the same, because white space is handled quite explicitly in the bash terminal. And you can go into all sorts of issues later down the road if you have white space going in all sorts of different directions. So I've created my new file. And for those of you that are here in Python 1 a couple of weeks ago, you'll see that we can do the ls command, and we will see that our new file is in there, is in this directory that we've made, and also this thing called textput.log. And that is created when we initialized our repository using the Git init function, the command, sorry. So now what we'd like to do is we would like to tell Git to automatically keep track of the changes that we make to this file, because currently all we've done is initialize the repository and put a file in a place. We haven't said to Git, we need you to look after this using your fancy version control magic. So what we need to do first is just to check that what I've said is true. We can run something called Git Status. And notice here that we're following the same format. If we want to do something in Git, we always say Git first, and then the command that we want Git to carry out. So if we go Git Status, we will see that we get some more text, and it says on branch master, so that's where we are right now. There have been no commits, and there are some untracked files. And here it says test new file.txt is untracked. So we know that what I've just said is correct. The version control system, Git, is not, it hasn't been told to look after this file, but it knows it's there, and that's a good thing. And it also gives us some information at the bottom that says, okay, nothing has been added, but there are untracked files present, and it tells us if we want to track them, we need to use this command Git Add. Now, before we add this file, there is a little bit of a middle ground that we have to cover, and it's called the staging environment. So each commit, the term commit, is a record of any changes that we are making to our files. So if you make a change to your repository, so by adding a file or modifying it, we then tell Git to put these files into a commit. And this is part of the middle ground, what's called the staging environment. So to add a file to the commit, it needs to be added to this staging environment. And this is using the Git Add, our file name, which came up on the terminal. And once you've added it to the staging environment, you can then tell Git to package it into a commit using the commit command. So this staging environment is quite important because it takes you from Git not looking after your files, and you go across the staging environment and Git starts looking after your files. So what we have to do now, as it's told us to do, is we go Git Add, and then our file name. And so my file name here was test new file file.txt. And again, exactly the same format. We always start with Git. We then use our command that we want Git to do, and then whatever it is that our command is going to act upon. So we're going to add it, and nothing comes up, but that's fine. It's executed. There's not been an error message. Everything's good at the moment. What we can have a look, we can see to check that something's happened by again running our Git status command. And here we have on branch master, no commits yet. But what we have said here is changes to be committed, new file, and it's committed in green. So we know that it's ready to be committed, it just hasn't been yet. And I see that there's been a question, I think, saying that the touch test new file text won't work. I don't think it will work on the Windows Anaconda prompt. I think you need to be in Git Bash for all of this to work. Obviously, that's where everything here is packaged up on the Windows operating system. So we know now that there are some changes to be committed, and we've used Git Add to add it to the staging environment. Now we need to commit this file. And again, very easy, Git commit, and then we type this flag called -m, and I'll explain what that means in a minute. And when we need to type a commit message. So I'll call this our first commit. But just like when making the environment, when you have to give it a name that you're going to understand in the future, when you're writing your commit message, you need to put something here that makes sense to the people, to yourselves or the people that you're working with, so that they know what the changes are or the new files are that you are putting into this repository. So if you come back to this in 6 months' time and you want to know, well, why did I make that file? Or if we were altering a file, you want to know, well, what alterations did I make? So my message here of our first commit is actually pretty poor message. What we'd want to really say is beginning file for project, Oh, something's come up, for project test. And this -m here is simply a flag that says, right, afterwards we can write a message. So when we commit this, we press enter, and quite a lot comes up, quite a lot to unpackage. So it says here, this is our message, beginning file for project test. The committer, that was me, and this is my my local address, and it's just saying here that the email address was configured automatically based on my username and the host name that we're using. That doesn't really matter, but what matters and what you should take away from this is version control is now tracking these files as we write them. So and at the bottom here, what I'll highlight is that one file has been changed, and we're in create mode, and it's the test new file.txt that's been changed. So it explicitly tells us what we've done here is on this test new text file, and there's been one change made. And if we go on to continue with this, you'll see that the files change. That number will go up and up, and if we delete them, the 0 will go up. And so it would really keep track of everything that's going on. What we might want to do now is just check Git status and to check where we are at in everything that's gone on. And so if we run our Git status command, and I've lost it on my screen, we will be able to see, yep, that on branch master, the untracked files, our text file, our test new file text has now been removed from this list of untracked files. And there's only the textput.log, but don't worry about that. So we know now that it's being tracked, and that's fantastic. So what we've done here is we've taken one file and we've basically tasked version control with looking after that file and tracking any changes or alterations that are made to it. But what if that is a code file and it works well for what we need to do, and there are people that are using it that are relying on this continuing to work? You don't want to make any changes to that might break it, or you certainly don't want to make any changes to it before you've tested it, because you obviously you don't want to break it, and you also don't want to bring it offline, because if people are using it, if you bring it offline, they won't be able to use it anymore. So we need to do something called branching. And what this does is it creates a branch. If we think of a tree, a branch, it goes off to one side from the main tree trunk, and it allows you to then change between states of a project. So if you want to edit a particular part of the code base, you could create what's called a branch, and just for that part, and it won't affect the main part of the program. So you can then go ahead and make edits without the worry that everything will come crashing down around yours and everybody else's heads. So if you then make those edits, and then once you're happy with it, you can then merge these branches back into the master branch. So once you said, right, we've updated this code, we now know it works. It works better than the old code. We want everyone to be able to use it. We then merge it back into the master branch, and Git will then know that this is the new thing that it needs to be keeping track of. But it also knows that it used to be a branch. So it will keep track of absolutely all the parts of the history of what you've done. So to create a new branch, we have to do this git checkout b, and I will just call this branch example. And again, we're following the same format. We say git. We want to check out onto a new branch, and we're naming what this branch is here. So if we run that, we can see that we've switched to a new branch called branch example, and you can name your branch anything that you like. And this is just referred to as checking out onto a new branch. And if we just run the command git branch, we'll see that we have our master branch, and which I suppose is, as I said before, that's kind of like the tree trunk, and our branch example. And the branch example has come up in green, and it's got an asterisk next to it, because that's the branch that we're currently in. We've checked out onto it, and this is what we're currently operating on. If you were to switch back and make commits to the master branch, the new branch wouldn't see those commits until you merged everything. So this is something that's very important to understand, because you are basically taking it away, you're putting it in a sandbox, and you can work on it whilst it's in that sandbox, but you can work on it without fear of breaking everything. But one of the things you have to think about is that until you merge it back into the master branch, none of the changes you make will affect the application and the way it works. So let's assume that we've now finished editing our new branch, and we want to put it back into the master branch. Oh, I think someone's turned their microphone on. Yep, great, thank you. So what we want to do is we want to switch back to the master branch. Again, this is very easy because we want to check out onto the master branch. So we say git checkout master. And again, we've switched back to our master branch as it tells us here. And we then want to merge our branch with the master branch because it's been well tested, it's been well formatted, and we know that it's not going to break anything. It's going to improve our code base for the better. So we can say git merge branch example, because I called mine branch example, whereas you might have called yours something different. And actually what we get is it says it's already up to date. But that's absolutely fine, because what we've done is we haven't actually changed anything in this tutorial in the branch. So it's just telling us that actually you didn't do anything, therefore everything's up to date. But if we had changed something in the branch example, so if I go git checkout branch example, and we change something, so we make a new file, so we say our new test file. Actually, that's a pretty poor name, isn't it? So we'll say our branch test file.txt. I don't know what this is, so let's snooze that. We can see that we've created it. So now what we want to do is we want to go back into the master branch, and we want to merge branch example. And again, it's saying it's already up to date, because what I should have done, I should have edited the text file instead of making a new one. So I think that's everything you need to know to be able to use Git. We've run through what version control really is, how we can use it to keep track of our files and all the commands that are needed. how we can use it to edit files without fear of breaking everything and then merge them all back together. And I think I'm a little bit ahead of schedule here. I think we've got a few more minutes. Sammy and I will then go on in the next session to show you how to collaboratively work using Git on GitHub, which is just a cloud-based version of Git.